Oh, good afternoon. How are you? How are you? Doing well. Are you getting tired yet, or is there still room? Is there still room up here? Yes? Okay, very good. Very good. Well, my name is Scott Davis. I am looking forward to giving this talk because how many of you in here are Java developers? Of course. Yes? Now, listen very carefully. How many of you hate JavaScript? Hate it? Oh, there's some hands to go very quickly as well, yes? This is such a problem, isn't it? That Java developers hate JavaScript. You want to know a dirty little secret? JavaScript developers hate Java as well, right? So why is it so hard for us to get along? As I mentioned in my keynote yesterday, Jazz or Classical, if you weren't there, the slides are still up on my website, thirstyhead.com. Jazz, do you prefer Jazz or Classical was my way to begin discussing whether you prefer JavaScript or Java, but without talking about the languages, because that could be fairly emotional. So what I also tried to do in that keynote is not dive into the technical details. I wanted to talk about the projects at a very high level. This is going to be a very similar talk in spirit, but this talk we are going to talk about low-level details. I'm going to show you syntax, because I do think that a lot of the hatred, and I will say hatred, a lot of the hatred that the Java community displays towards JavaScript is just understanding, or misunderstanding, I should say, that we have these expectations that this thing called JavaScript should look like Java and behave like Java and maybe just be a lighter version of Java. And we'll touch on that a little bit. But that couldn't be more farther from the truth. That these are two very different languages. But what's interesting is in this latest version of ES6, which is the latest version of JavaScript, this latest version of ECMAScript 6, JavaScript took a big step towards being more Java-like. We have classes, we have modules, we have hash maps and sets, and a lot of you are nodding your head saying, oh, this all sounds very familiar, which is a good thing. So that should very much help you feel more comfortable with JavaScript. I'll also touch briefly on TypeScript, because the number one biggest difference between Java and JavaScript boils down to one thing, doesn't it? Types. Yes, Java is a statically typed language, which means you say string name equals Scott. Int age equals, I'm not going to tell you my age, 47, okay. Int age equals 47, those kinds of things. You have to specifically data type your variables. You have to specifically type your method signatures. Every class has to have a specific type associated with it. So TypeScript very effectively superimposes a type system over what's fundamentally a dynamic language. So we've got a lot of things to talk about here. The title of the talk was What's New in JavaScript, but the underlying essence here is this is now JavaScript for Java developers. And with ES6 specifically, I think there'll be some things that should appeal to you specifically. So we've got a lot of material to cover here. And then we have the town hall afterwards. It's going to be in this meeting. That's going to be an open Q&A session. I hope you're planning on joining us for that as well. So when Angular 2, which is now officially out, and it's not even called Angular 2 anymore, right? It's called Angular 4. Oh, things move so quickly, I tell you. But when they started with Angular 2, they said, we want to build Angular 2 for the browser of the future. And specifically, you can see they call out, that involves things like web components, which I've been talking about a lot since I've been here, and ECMAScript 6. Well, the good news is, ES6 is here. And Angular 2, in fact, takes advantage of a lot of these new language constructs. So what we want to do here is we want to focus on a lot of these new language constructs. Now, JavaScript, of course, has had strings for quite some time, but we'll get a chance to talk about some of the new methods that have been added to strings. But then more importantly, we'll get a chance to talk about metaprogramming. Dynamic languages can do interesting things, so we'll use that as a touch point to examine the differences between Java and JavaScript. We'll talk about maps and sets. And I know that you already know what maps and sets are like, but we'll talk briefly about them and why they're interesting to JavaScript. We will talk about constants and let, a new keyword, and we'll use this as an opportunity to discuss lexical scoping and how the let keyword makes variables behave far more like Java than they ever have in the past. And then we'll wrap up talking about classes, modules, imports, and exports. And again, the syntax and the ideas shouldn't be new to you. We can use this as an opportunity to compare and contrast. So this is going to be a nice combination of new syntax for you in terms of JavaScript, but we'll have a special effort to compare and contrast with Java. Are you ready to get started? Yes? Outstanding. I am as well. So I believe that one unit test is worth 1,000 opinions. And I would hope you do as well. So a lot of the examples I have here are actually up on my account, up on GitHub, GitHub/ThirstyHead, but they're a series of ES6 tests. Now, some people look at that and say, my goodness, Scott, consider the brazenness of Scott, that he is looking for bugs in JavaScript. Can you believe that? No, I'm not looking for bugs at all. That's only one thing you can use unit tests for. Another thing you can use unit tests for is executable documentation. How many times have you written a little snippet of code, a little throwaway code, and then thrown it away? And then said, well, wait a second, now how did I do that against you? Write the snippet of code and then throw it away again, right? And so what we can do is we can start keeping those snippets of code around and actually treat them as executable documentation. The first time I saw someone do this was Mike Clark. Mike Clark wrote the JUnit book for the pragmatic programmers years ago, and he was teaching himself Ruby. He was learning Ruby as a Java developer, and so he sat down and started writing unit tests against Ruby. He's like, oh, this is how I do string concatenation in Ruby. Oh, this is how I split a string in Ruby. Oh, this is how I iterate through an array. Oh, this is how I do this and this and this and this. And you see what happened is that over time, as he was learning the language, he ended up with 300, 400, 500 unit tests, each one not looking for bugs, but giving him that source code example of how the language worked. I thought that was brilliant. But it got even better when the next version of Ruby came out. Did Mike throw away all those unit tests and write them over from scratch? No, of course not. He ran his unit tests against the new version of Ruby. And what did that tell him? Backwards compatibility. He instantly was able to tell what had changed, or more importantly in his case, what hasn't changed. What if he had 500 unit tests in one version of Ruby, ran them all in the next version of Ruby, and not a single one failed? What did that tell him? Nothing's changed. Or at least my knowledge is still valid as I move on. So that's a long explanation of why I started doing these things in unit tests. And I would encourage you to use this same skill when you're learning a new library, learning a new API, learning a new framework, or even learning language features like this. Create a series of unit tests, because we're all writing unit tests, right? Yes, of course we are. But it'll also give you that corpus of knowledge, that executable documentation to carry with you. All right, enough talking. Let's dive in. So I've mentioned ECMAScript a couple times now, and it's worth explaining what that is. ECMA, the European Computer Manufacturers Association, is the organization that standardizes JavaScript. The W3C, the World Wide Web Consortium, is responsible for HTML and CSS, all the document aspects, all the DOM aspects of things. But our JavaScript runtime is managed by a different consortium, the European Computer Manufacturers Association. So there have been a number of releases. Java has had 8 releases, since 1995. JavaScript has had 7 since 1995. And why is 1995 so important? That was the very first time that both Java and JavaScript were introduced to the world. Java was first made public in Netscape Navigator 2.0 through applets. And JavaScript was introduced to the world through Netscape Navigator 2.0 as well. So as we look through the various versions, you're probably comfortable with Java versions. I got started with Java 1.1, and so I remember Java 1.2 when it came out. Oh, we moved from AWT to Swing. We got our collections. You probably remember the key new features that came out in various Java versions. Oh, in Java 6, we finally got, in Java 7, in Java 8, And so being able to do the same thing in JavaScript is helpful. So version 1 was basically what came out in the very first version of Netscape Navigator. It's the very first version of JavaScript. But ES2 and ES3 specifically are very important because you'll see ES3 came out in 1999 and the next version didn't come out for another 10 years. So in that period, that was the Internet Explorer 6 years. If you want to think about what Java looked like at the end of the 20th century in 1999 in IE6, it's basically ES3. So that's one major version of JavaScript that you should be aware of. What happened in ES4 was interesting because there are a lot of members of this consortium. Microsoft was in this consortium, Netscape was in this consortium, a lot of different organizations. But they were really drawn to this idea of adding types to JavaScript. And it was such a contentious issue that they could not come to an agreement, and they scuttled version 4. They just didn't release it. That's how contentious data types were. So it took 10 years, but they finally let all of the emotions calm down. They finally found a compromise. And so they released ES5, but they also called it Harmony because they were trying to build peace back into the organization, build some consensus back in the JavaScript team. ES5 was important because it was the first major new JavaScript release in a lot of years. But it didn't add a whole lot of new features. That was ES6. Do you remember when Java stalled at Java 1.6? That we were stalled at 1.6 for a lot of years? That was during a transition time when Sun went out of business and Oracle acquired them. That also was a transition in leadership. That's when Brian Getz took over as the architect of Java. He's the current architect right now. So he was trying to just get some release out, just something out to prove that, hey, Java's not dead. We can add new features. We can get this car rolling again. And so do you remember what the code name for Java 1.7 was? Project Coin. Do you ever know why that was? Because it was spare change. It wasn't a whole lot of really important new features in Java 1.7, right? It was just enough to prove that, hey, we're back in business. Java 1.8 was a whole lot of new features, right? That was the new Lambda stuff and all the other good stuff going on. Yeah, so really, Java 1.7 is to ES5 as Java 1.8 is to ES6. And by that I mean the former was a release to prove that the language wasn't dead after being stagnant for a while, but the next release is where the good stuff happened. And in our case, ES6 was that next release. ES7 came out last summer. ES6 came out in the summer of 2015. ES7 came out last summer. Not a lot of really important new features. It just kind of snuck in. No one made a lot of big deal out of it. But ES8 will bring some important new features as well. But ES6 is the point of this talk. The features in ES6, classes, a module system, generators, iterators, destructuring assignments, algebraic data types, those are the maps and sets. All of these features that were identified as candidates for ES4, that failed version, they finally shipped in ES6. That's why they called it the Harmony Project. They said, finally, we came back, we got some good things in place. Notice I left one important thing out of that list, static typing. That did not come back. Yeah? But basically, this failed list of features for ES4, modulo static typing, is what finally came in ES6. Long time coming, but well worth the wait. So I mentioned TypeScript as well. TypeScript didn't come out of the ECMA organization. Interestingly, TypeScript came from Microsoft. The buzzword on the top bothers me just a little bit. TypeScript lets you write JavaScript the way you really want to. What? You know what allows me to write JavaScript the way I really want to? JavaScript. Yeah? But I know they weren't talking to me. They were talking to Java developers, and since it's Microsoft, they were talking to C# developers as well. Because they go on to say, TypeScript lets you write JavaScript the way you really want to. TypeScript is a typed superset of JavaScript that compiles to plain old JavaScript, any browser, any host, any OS, open source. Let's take a moment to consider using Microsoft and open source in the same sentence. Yeah? And I love poking fun at Microsoft. I've got over 15 Microsoft certifications. I've got a lot of history with Microsoft. I love what Satya Nadella has been doing with that organization. It's amazing how much open source is coming out of that organization right now. Their web browser is now open source. You can get at Chakra, their JavaScript engine, and you can get at Trident, their HTML renderer. Those are both open source. So now Internet Edge, Microsoft's browser, is just as open source as Chrome and Firefox and Safari. So they've really leveled the playing field. But it's amazing to me that TypeScript is an open source project and that it's the language of choice for Angular. So not only can I not believe that Microsoft open sourced something, they partnered with Google to do it. It's incredible. Will wonders never cease? Yeah? But these language features you see up here, these imports and exports, those aren't Angular features. Those are ECMAScript features. Those are ES6 features. This annotation that you see here, at component and at template, yeah, I called them annotations because I knew who I was talking to. JavaScript would never deign to call itself something that Java already called it, right? So we couldn't possibly call those annotations. We're calling them class decorators. Yes? But a rose by any other name is just as sweet. You'll see a lot of familiar features here. They might be called different things. But what I love about this example right here is there's really 0% Angular in that source code and 100% plain old JavaScript. Now, TypeScript, obviously, but nonetheless. So what we have now is ES5, which is the base layer. That's been out for almost 10 years now. Every modern browser has at least ES5 support, and so that's kind of what we start. ES6 features are pretty well disseminated now across all browsers. There might be an odd one here and there. And so a lot of people treat ES6 as a perfect superset of ES5. So we can begin deciding, oh, this browser has these features and most of these features, or these features and all of these features. But you can see TypeScript we should consider to be a superset of ES6. And TypeScript literally just allows you to add data types to variables, classes, and method signatures. It allows you to create interfaces, which literally don't exist in JavaScript, but they exist in TypeScript, so you can have interfaces and implementations as well. But that's all it brings. It doesn't bring a whole lot of new keywords or functionality or anything. The whole point of TypeScript is exactly what the name implies, is to superimpose a type system over ES6. Does that make sense? Yeah? Good. All right. So getting back to our good friend Angular over here once again, we say import component. Let me make that text a little bit bigger so we can make sure we're all on the same page here. You're used to importing, aren't you, in Java? What's the keyword you use there? Oh, wow, okay. Amazing, right? One thing is a little bit different than this. We have to surround what we're importing in curly braces. This is actually called object destructuring, and we'll talk about that in a little bit. You're familiar with annotations, of course. We call them class decorators, as I mentioned. You will notice that there isn't this notion of public or private, because in JavaScript, everything used to be public, right? Everything used to just be pathologically global. There was no way for you to make things private. There were some workarounds, and we'll discuss that as well, but there isn't this formal notion of public and private. What's interesting about modules now is everything in that Angular core module is private by default, not public. When JavaScript introduced the idea of modules, which is just a JS file, but when it introduced the idea of modules, it said, you know what? We're going to make everything private by default, and you'll have to explicitly export what you want to be public. And so that's why at the bottom of this page here, when we see class app component, in Java, you're used to seeing public class app component. In this case, we're saying export the class app component, so someone else later on would be able to say import app component from appcomponents.ts. Yeah? Good. All right. So I mentioned that browsers have pretty good support for JavaScript. That's a big concern from Java developers, right? The whole point is when I upgrade to Java 1.8, that platform gives me all my features. And that's great. I like that model a lot. But they can get away with that because Oracle is basically the only company making the platform these days, yeah? They're the ones that are writing the JVM for Windows. They're the ones that are writing the JVMs for Linux. And Apple used to be writing theirs, but now it's pretty much back on Oracle once again, writing those platforms. Now, when it comes to JavaScript, we have so many different platforms out there written by so many different vendors that it brings an interesting set of challenges to us as JavaScript developers. That's why sometimes something might be implemented in Chrome but not IE, or Edge, excuse me. Something might be implemented in Firefox but not Safari. So what we end up doing in that case, because we're in a dynamic language, because we can dynamically add new methods and new fields on the fly, is we polyfill in support. Polyfill is like spackle, right? You just kind of layer that in. So when we talk about using new ES6 features, a lot of times you'll hear people talk about transpiling your code. Is JavaScript a compiled language? No, it's interpreted, absolutely. So we can't really talk about a JavaScript compiler per se, but a transpiler is something that takes one bit of source code and translates it or compiles it into another set of source code. So in fact, if you're writing ES6 code, you might end up transpiling using something like Tracer, which takes that ES6 code and converts it back to ES5, which we know has been out for 10 years and has widespread support. This is how you can write code in ES6, but be guaranteed that it's going to work across all platforms today. If you're writing in TypeScript, there's not a browser on the planet that can speak TypeScript natively. It'd be interesting if Edge got that feature, right? You could say script lang equals TypeScript, script lang equals JavaScript. No browser has supported a different language up to this point. So if you're writing TypeScript, you need to transpile it to ES6 and then take that ES6 and transpile it to ES5 before you move along. Does that make sense? So Tracer is a transpiler. It came from Google, and this is the transpiler you'll probably end up using if you're using Angular 2. This is what a lot of the books recommend. But Babel is the cool kid these days. It's the one that a lot of people are dealing with. And so you can see allowing you to use next generation JavaScript today. This is just a library, and you make it a part of your build step. Just like you would compile your Java, you would transpile your ES6 into ES5 so you can deploy it. So there are a whole bunch of different transpilers out there that give you the same capabilities. So when people look across, hey, what ES6 features are available, and don't get too worried, this is an old screenshot as well. But when people look at all that red and they say, oh no, I'm never going to be able to use something like that, realize that the transpilers are what turn all those red features into green features. Because even though that browser may not natively support it, the transpiler will add those features back in so that you will be able to run it. Yes? So the concern was, does that kind of mess up your code? I'm paraphrasing, of course. Yeah. It actually probably cleans up your code. If you've ever worked in languages like CoffeeScript or TypeScript, what gets emitted on the other end ends up being incredibly well-formed code. So I would actually argue that going through this process might clean up your code and make it easier to debug rather than the opposite. Yeah, it's a good observation, though. All right. So let's start talking about the new language features we have available to us. As I mentioned, string is not a new language feature. It's been around since the very beginning. But we get new methods now. Things like string starts with, string ends with, string includes. Now, you've had various libraries, various functions like this in Java for a lot of years. But if you want to deal with strings in Java, if you want to make some method call on a string that isn't on that string, how do you do it in Java? You have to create a separate library, right? Like the Jakarta Commons library, the string utils and commons. There might be your own custom string library. But the reason why we can't add new features to string is because string is a final class. Yeah, the language has said, no, you absolutely can't add new features. Well, funny story, metaprogramming is the ability to add new features to existing classes, new methods or new fields. And this is a native part of JavaScript. So just like final is intrinsic to Java, and that's important because we're strongly typed and statically typed, and that's a way to make sure that that type doesn't get modified, we don't have those same concerns in JavaScript. So in fact, this isn't a bug. This is a feature, being able to go and add new methods to existing classes. So if I had a message like that, hey, I like JavaScript, and I tried to call message.shout, I'd get yelled at. I would get a compiler error, right? It would say, message shout, shout's not a function, what are you talking about? The way I would fix that is very straightforward. In Java, everything is class-based inheritance. I would say, my new string extends string. And that's what final specifically blocks. I can't extend a final class. Yeah? But in JavaScript, we have this notion of prototypes. And prototypes are all that shared behavior and fields floating around, but they're in fact their own function. So I can take one prototype from one type of object and apply it to another object. I can turn around and have multiple parent inheritance in JavaScript because I can pick and choose the prototypes that I want and merge them together. So when I'm doing something like this, in fact, what I'm saying is string.prototype.shout. I'm saying, guess what? Every new string that I have in my system right now will now have this shout method. Does that make sense? So this is one very common thing when Java developers get frustrated. They're like, how come we don't have final classes? Well, because this is a dynamic language. Well, then what about some of the anti-patterns we have in Java, like a bunch of static string manipulation methods that take a string and return a string? What if we were able to do something like this idiomatic in JavaScript that would short-circuit that problem? I'm not going to argue better or worse or one or the other. I'm just saying that this is how we would solve something in a dynamic language, and you have a different set of gang of four patterns to solve things in Java. Yeah? Excellent. All right. Well, here's something else fun we can do. You've got templating in Java, but when did template strings join us in Java? 1.7. Yeah, Project Coin. Yeah. That was the ability to do multi-line strings. Yeah, it gave us the ability to do string interpolation, good things like that. Well, we got it in ES6 here. These template strings are just that. They're multi-line strings and they are string interpolation strings. We'll talk about both of those things. But the way you create these new template strings now are using backticks. In Java, you can use double quotes or single quotes, right? And you can embed them. If you've got single quotes in there, you'll wrap them in double quotes. If you've got a double quote in there, you're going to wrap them in single quotes. Yeah. Same is true in JavaScript, but now we have backticks. We have a third way of dealing with that. And some people say, well, how come we just didn't add that functionality into single and double quotes? That would have been nice, and then it would have been one less magic symbol we have to keep in mind. Well, we could have done that, but then we would have broken backwards compatibility. And JavaScript is just as concerned with preserving backwards capabilities as Java is. And so the way we solved that is giving ourselves a new symbol. So once you start using that symbol, the old way to deal with strings was a string plus a new line and a string plus a new line and so on, doing that string concatenation kind of stuff. That bottom example, using backticks, even though that string spans 2 lines, it effectively is one string. This is such a powerful feature that Angular 2 uses this to define all their templates. It may be hard to see, but they say template equals backtick, and they do all that magic stuff in there. And this is a great example of using templates. Notice they didn't have to escape out any of the internal quotes in there, any of the internal double quotes. They were able to copy and paste HTML in, or they could have copy and pasted XML in, or they could have copy and pasted CSS in. They wouldn't have had to escape out anything at all by using those backticks. But you might have noticed something else in there as well. Things like hero ID, things wrapped in double curly braces like title. Well, That is called string interpolation. Rather than saying something plus something plus something plus something, that's string concatenation, yeah? String interpolation means we're going to embed all that stuff in that string. And you'll see how we do it in there. We do it with a $curly brace. And if you've ever done any ant programming, if you've ever done any groovy programming, this should feel very comfortable to you. But what that means now, 15 is $A plus B. That calculation happens in place. And that $curly can contain anything. It can contain method calls. It can contain multiple calls, semicolon delimited. You can do whatever you want to in it. It's basically an executable block of code inside of your string. This kind of templating is something you maybe have been used to doing in JSPs, but it's so nice being able to do it in the core language. We have template libraries in JavaScript like handlebars or JSX or things, but it's really nice knowing that we can do this templating at the language level instead of the library level. So let's talk about algebraic types now, maps and sets. Now this definition is one of the best I've read. A map is simply a key value pair, right? Sometimes I call them hash maps because that's kind of a little bit more of an implementation detail, but a map is simply a key value pair. And a lot of people have historically said, well, you know, why can't we just use an object literal? You knew that JavaScript was object-oriented, didn't you? JavaScript didn't have classes, but it was object-oriented. I'm going to say that again. JavaScript didn't have classes, but it did have objects. Because we're a dynamic language, we can define classes all day long, but we don't have the ability to extend classes or have child classes or any of those kinds of things. We didn't until ES6. And so we would end up doing what we end up seeing here, which is just anything you create in curly braces is in fact an object literal. What does JSON stand for again? Help me out. JavaScript. Oh yeah, so yeah, we have had this for some time, right? But this object could have fields, which are named value pairs, but it could also have behavior. It could also have functions and other weird things in them. So we've just used object literals as maps for a lot of years, but it was odd because you could have other functions in it and other kind of things like that. So we can just now just do maps. So we can say var map equals new map. We can say map set equals key, value, value, value. And this is a very common idiom in here with maps. You'll have your key and the value, in fact, will be a JSON block. So that's how you can store multiple values in there. So it's almost disappointing seeing this in action, right? It's like, well, I've had maps for years in Java, and this behaves exactly the way I'd expect it to. And that's kind of the point as well. Sometimes new features don't have to be exciting. Sometimes new features can be, oh, finally. Because there are a whole bunch of convenience methods that come along with this. You didn't have to write your own delete key or clear out all the keys, or your own for each to loop through all that stuff. These are all things that if we were just dealing with object literals, we had to kind of deal with on our own as well. And now we have a nice rich API that allows us to walk through and do all kinds of fun, mappy-like things. Does that make sense? Yeah? Maps. Good. Well, sets are much of the same. We have array lists in Java, and we have sets in Java. And I always get confused. What's the difference between an array list and a set again? Help me out. What's set? I'm hearing set, mumble, 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 mumble. So what's set? What's the important bit about a set? It can't contain duplicates, exactly. An array list preserves order and allows duplicates. A set doesn't preserve order necessarily. Its main concern is this uniqueness constraint. And so sets are just the same in JavaScript. What's interesting, though, is equality is a little bit funky in JavaScript, isn't it? In Java, you use a double equals, right? In Java, a single equals is the assignment operator. String name equals Scott. And then if I want to test it, I would say assert name double equals Scott. Well, because things are strongly typed in Java, that double equals is making sure that this is a string and this is a string and the first character is this first character and the second character, so on and so forth. It's not only doing value equality, but it's doing object equality as well. In JavaScript, if you use that double equals, it does something called a truthy evaluation. Literally, it does type coercion. And that's why you get all of these examples on the web. How can 0 equal false? How can 1 equal true? How can the string 1 equal the number 1? All those types of things. All that is because when it comes to using the double equal sign, the value on the right is coerced. The data type of that is coerced to try to match the value on the left and then do equality that way. It sounds complex, but in a dynamic language, many times it's more of a convenience than a hindrance. But here's the deal. I rarely use double equals in JavaScript. I almost always use triple equals. And triple equals is strict equality. And triple equals will behave much the same way that a double equals works in Java. In that the triple equals ensures that we don't do any coercion or things like that. This whole value equality is very important. The set evaluations to make sure that they're unique uses triple equals equality, not double equals truthy equality. So it is in fact using strict equality. But here's what a set ends up looking like. Var set equals new set. 1, 2, 3, 4, 4, right? So when we go to console log that out after the fact, no one should be surprised that that second 4 isn't around. In fact, it's the first 4 that's not around. The second 4 replaced the first 4. Yeah? So sets, and we have that wonderful API in there as well, adding values and clearing values and getting the entries and all manner of fun stuff. So these algebraic types are a nice addition. Those string values are a nice addition. But none of these were real game changers yet. I told you that ES6 was a big, big release. But I've been giving you kind of the Project Coin features up to this point. Const is an important one. And I know you're saying, well, we've had constants for a long time. But remember, we're in a dynamic only reference to the value. It doesn't mean the value is immutable. It means the pointer, although we don't have pointers, right? Java doesn't have pointers either, do we? Yes, the address reference to that value is what's constant. And this is an important distinction. Because if I say const my age equals 7, and then, my fave, and then later on I try to do my fave equals 20, well, that's going to throw a compiler error. That's going to be bad things happen, yeah? But if I did something like this, const my object equals this object literal, and later on I change that object literal, nothing happens. Because the reference to my key has stayed the same. We just happen to have a dynamic object on the end of that reference that can be changed dynamically at runtime. And I know it sounds like I'm making excuses for this. I'm really not. This will frustrate you, which is why we're talking about it, yeah? But we're in a dynamic language, so the expectation is, of course, everything should be able to change at any given point. In ES5, we got a new feature called Object Freeze. And if this sounds a lot like const, it is, but Object Freeze is how you freeze the right-hand side of the equation. const is how you freeze the left-hand side of the equation. So if you create a constant reference to a frozen object, finally, I have a constant like I would expect to have as a Java developer. Does that make sense? These aren't hacks, these aren't workaround. This is internally consistent within the language, but because the paradigms are different, Java developers tend to get frustrated at paradigm mismatches. And this is a key paradigm mismatch. All right. Let. This is another interesting new feature. And I could just say from now on, stop using var and just use let. And that would be effective. That would make variables behave far more like Java variables than the var keyword ever allowed. Because the var keyword, in fact, is the way we make global variables. If I say var name equals Scott, the name is a global variable. If I just say name equals Scott, name is still a global variable, right? And you're like, well, wait a second, that sounds ridiculous. And it is ridiculous, right? I mean, this is an old language. But if you use the var keyword inside of a function, that makes that variable private to that function. Once again, if I have a function and I start creating variables using the keyword var inside of that function, that is the only way I can get private variables in JavaScript. And we say that it's lexically scoped to that function. You can't get at those variables outside of that function. Now, Java has the same idea of lexically scoping, but in Java, we don't limit our lexical scoping to just classes. In Java, we lexically scoped any variables defined in any blocks, in any curly braces. So if you have an if block and you declare a variable inside of that if block, it's scoped to that if block in Java, isn't it? Whereas in JavaScript, it's not, unless you use the let keyword. The let keyword does everything var did, but by default, it lexically scopes things rather than globally scoping things. So in Java, if you're trying to iterate through an array and you say for int I equals 0, I less than length, I plus plus, right? I is lexically scoped to that for loop. In JavaScript now, if we say for let I equals 0, I less than length, I plus plus, that I variable will behave exactly the same way it did in Java. So the short answer to this is just start using the let keyword. Just start using it everywhere. That's what I do. I now use var with intent. I use var when I explicitly want to create a global variable. And you want to know how many times I want to explicitly create a global variable? Never! Yes, I'm really enjoying this new lexical scoping. So I'm really enjoying my new let keyword as well. So this is what it ends up looking like. Hey, if x is greater than y, let gamma equals this, and gamma is only scoped to that if block. If we do things like this, function var test, var x equals 33, great, that's scoped to that function. But later on, if you say var x equals 71, rats, we've just stomped that same variable because it's in the same lexical scope, right? You may think that you're shadowing it in an if block, which is never a good idea either, right? Great source of hidden bugs there. But because you have those things, if you're looking at those in Java eyes, you might say, I'm safe. In fact, you're not. Change it to let, and you're in business. Yes, sir?
Yeah, so this feature is in ES6, right?
Yes, ES6.
And we are saying that there are methods to convert the code from ES6 to ES5.
Yes.
Now, there is nothing called let in ES5. And as you said, there was no way to make things lexically scoped in ES5. So how does this work in ES5?
I am so glad you asked. Oh, I thought I had a slide explaining it. I am really disappointed that you asked. Rats. No, we have this thing called an IFI, an immediately invoked function expression. And so what our transpiler will do for us, it'll take all of our ES6 code using the let keyword, and it'll transpile it back to ES5, and in fact, wrap all those invocations in IFIs. So it's effectively giving us that scoping using a Java 5 idiomatic way to accomplish it. Very good question. Very good question. What I like doing more than anything else is just looking at the transpiled code. I love that with CoffeeScript. I learned more about JavaScript using CoffeeScript because CoffeeScript was a very Python-like language. It uses in a significant white space and a lot of things like that. So I would write CoffeeScript and look at the code that it emitted, the JavaScript code, and it would emit this amazingly tight, efficient JavaScript. So it taught me good things about how I would write my own JavaScript. I encourage you to do the same thing with your ES6 code. Look at the ES5 code. You'll learn how to do a lot of these features in ES5 by using IFIs and various other constructs. Yeah? Destructuring. This is where my Java is going to get weak. Did we get destructuring in Java 1.7 or 1.8? I think we got it in 1.7, didn't we? Groovy has had it for years, and that's why I can't remember when I got it in Java, because I've been doing this stuff since the last century, right? Deconstructing is really interesting. It may look like a little bit of syntactic sugar, but all it means is it's a convenient way for you to declare more than one variable on the left-hand side of the equal sign and assign it to various aspects on the right-hand side. So that first example, we have an array that has two elements in it. We're using square brackets to define an array. So in order to destructure that, I would use square brackets on the left-hand side. I would have two variables now, A and B. A contains, the value 1, and B contains the value 2. So just nice syntactic shorthands there. Where it gets really fun is where you get that triple dot in there. That's called a spread operator. And what that means now is I will have two variables, A and B, and then just everything else will be a new array called the rest. So this destructuring is a way for me to pull values 1 and 2 out and then just keep everything else together. Yeah? So these are all the fun things you can do with arrays. Now, when you're dealing with object literals, you use curly braces, but it works exactly the same way. And this is where it gets really interesting. Imagine a person object that has a first name and a last name and an age and an address with a steady state, zip code, all kinds of good things in it. That person might have a dozen fields, and you really only care about the first and last name. So what you can do is object destructuring. You can say, I just care about first and last name in curly braces on the left-hand side of the equal sign. And then you could just say that equals person, right? And then all of those other values inside of person would kind of get thrown away, and we would be left with a new object on the other end. So array destructuring is a lot of fun. Yes? Yeah. So, and I can make this a little bit bigger to make it extra clear. So on line 3 there, this example, A, B, and then ... the rest. That ... is an operator in JavaScript. It's called the spread operator. And what it means is take everything else that's remaining and throw it in here. So it really was just kind of positional in this case. And as you can imagine, that destructuring, you couldn't use that as the first argument in there. It really does mean everything that hasn't been allocated yet. Does that make sense? No, still no, huh? Ah, it's a cool new feature. You got homework now. All right. The reason why this destructuring is so important is when we look back at that import statement, import component from Angular 2 core. Angular 2 core is a module, but component is actually being destructured out of that. You can imagine that Angular 2 core has a number of classes and a number of helper methods and a number of even just constant variables in it that you might be interested in. So you can import any number of them. In our case, we're just importing one class out of there through that destructuring syntax. It's a curly brace because modules are treated like JSON blocks. They're treated like object literals rather than arrays. So you use the appropriate symbol to destructure the appropriate type of thing. So every time you're importing and exporting, you in fact are destructuring. Congratulations. It's a fun feature. Arrow functions. We come back to lexically scoping once again. Let is the variable keyword that allows you to lexically scope things. These fat arrow functions lexically scope as well. If you've ever done any AJAX development, you know how frustrating it is when you make an AJAX request out for a person object. And when you get that person object back, you say this.last login time equals something, right? You're expecting this to point to person, but in fact, this is pointing to the AJAX handler out there. It'd be really frustrating. So in JavaScript, you'd see a lot of people do var that equals this, and then you'd say that.last logged in. You'd do a lot of things like that. Well, you don't have to do this that equals this equals that anymore. You use fat arrows, and they're naturally lexically scoped to what you'd expect them to be scoped to. So these two functions are equivalent at this point. AMAP is a function S that has that return S length, but you'll see here as well that shorter fat arrow syntax. Anytime you see a fat arrow, it's the equivalent to a function. It does exactly that same thing, but it's lexically scoped. It doesn't break this anymore. So fun stuff going on there. That set interval, right? If they wanted this person to age every second, set interval takes a function, and then that very last argument, 1,000, is milliseconds. So this would be incrementing that person's age, or you were hoping it would be incrementing that person's age. But unfortunately, this plus plus would be pointing to the grow-up function, not the person function being closed around it. So all you have to do is take that same set interval, but use fat arrow syntax, and then all of a sudden it works exactly like you would expect it to. All right. So classes are what I want to talk about. We just have a few minutes left here together. Classes are really just syntactic sugar. Really, at the end of the day, classes are just syntactic sugar in Java. JavaScript still maintains classes the way they always did, using that prototype-based inheritance. But every framework on the planet, the first thing they did was they superimposed a class system back onto JavaScript. We really like the idea of classes. We really like the idea of having bundled fields and functions that come along for the ride. We really like the idea of having a person object that we can extend. We really like being able to call superclasses. All of those things now are available to us in JavaScript. The really nice thing is they did it in a backwards compatible way. They introduced new keywords, but the underlying implementation is the same implementation that's been around since Netscape Navigator 2 back in 1995. So this is the perfect new feature for me because I can continue to treat functions like functions if I choose to, but if I like the syntactic sugar, I can leverage it as well. So all of a sudden now I can say class polygon. Oh, isn't that nice, finally. And I have a constructor method. In Java, your constructor is just the name of the class. In JavaScript, the constructor is this function named CONSTRUCT. Yeah? So there's our constructor right there. But we're saying this height and this width, the way you declare fields now is inside of your constructor. So a polygon now has two fields, a width and a height. And so later on, you can do up that polygon just like you would expect it to. So you can start doing other interesting things in there as well, right? You can define them. You can say var polygon equals class or volley polygon equals class polygon. This is how I end up doing it. This is the shortest and most succinct, just class polygon. So now we can start defining functions like area, like calc area, like these kinds of things. And so you can see all of these thises work exactly the way we would expect them to. This doesn't apply to calc area anymore. This applies to the class. So fat arrows, classes, lets, all go a long way for solving those frustrating lexical scoping issues. We can have class point that has a static method distance on it as well. Now we don't even have to say new point. We can say P1 equals new point, P2 equals new point, and then the point distance is a static method that we do whatever we want to on it. We have subclassing with extends. Class animal has a speak method. Dog extends animal and overrides the speak method. I'm moving through this very quickly because if you haven't figured this out in Java yet, I don't know what you've been doing all these years, right? You'd be hard-pressed to be successful in Java with having these kinds of things. We have the super keyword as well in there. That allows you to do what you'd expect to do, which is call the parent class. So now in our overwritten speak method, we're going to call our parent speak method first, and then we are going to call our own custom behavior. So finally, we leave off with modules. And this is really kind of interesting because modules don't involve a new keyword or a new file extension or anything. Now keep in mind, those are still things that people are talking about. They're like, it would be nice if we had a module keyword, or maybe we would have a JSM file, a JavaScript module file. It would be nice if there was some way we'd be able to identify this. But right now, every separate JS file you write is a module. Every JS file you now deal with, you're expected to do imports and exports and manage things that way. Oh, there's that iffy argument. I knew it was in here. I knew I wasn't crazy. So an immediately invoked function expression ends up looking like this. You end up wrapping the function in round parens and then immediately executing it. And so any variables that you defined inside of that function would then be private to that function. But in our case, we use import and export. So if we have a module that has a function called detect cats, and we also have a class called kittydar, and we have another function in there, notice that when you export the class, you'll be able to import it. When you export the function, you'll be able to import it, but resize canvas is now effectively private. So later on, when you import detect cats, you're using object destructuring. If you wanted to import multiple things from that, you would still use object destructuring. Yeah? Excellent. So when we look at this hello world example one last time, one of the things I like most about Angular is all the JavaScript in it. Specifically all the ES6 in it. Because this is a framework, and they're not the only one, but this is a framework that said we want the world to look like what modern browsers are going to look like. And ES6 did a wonderful job of embracing service workers and web components and templates and certainly all the new language constructs of ES6. Did you enjoy yourself? Are you hating JavaScript a little bit less? I don't ask you to love it, but do you hate it just a little bit less? Good. Then my work here is done. Thank you so much.